Once they agreed on the prime meridian that runs through Greenwich in London, they were able to work out time zones for the rest of the world. And the way that they did this was basically by imagining the world like a giant chocolate orange. Don't know if chocolate oranges had been invented in 1884. But they imagined the globe as a big ball that was cut into segments like an orange. And it looked like this. And each of the lines is a different meridian. So each of these white lines running around the outside goes from north to south or south to north and is a different meridian. So how do you think they decided how many segments to cut the globe into? Have a look at the globe and see if you can work it out. That's right, they used the hours in the day to split the globe into sections. And I'm going to show you how. There are 360 degrees. When the Earth is spinning on its axis, it turns 360 degrees in one day. And you will have seen that on things like these protractors. Okay, so the half protractor that goes up to 180 for going in a semicircle, and the circular, the full protractor that goes all the way around 360 degrees and back to 0. So they've got the globe that is turning 360 degrees in a day, and the day is 24 hours long. What do you think they did to work out how big the segments needed to be? Well, they took 360 and they split it into 24 chunks, and each chunk was worth 1 hour. So they did 360 divided by 24, and if you do that, you get 15. So every 15 degrees that you move around the Earth, you move 1 hour forward or backwards in time. So imagine that you started at a point here at 0. This would be your Greenwich Mean Time. I'm just going to put a G for Greenwich Mean Time. If you moved 15 degrees, well, here's the 10, so this point must be 15, then that would be plus 1 hour. And then as you got up to 30, that'd be plus 2 hours, and then 45 plus 3 hours, 60 would be plus 4 hours. Can you see how each of these would be one of the segments, like in our orange? So each segment is 15 degrees of a turn. If we look back at our flat map, this is what it looks like. The Greenwich meridian, the prime meridian, is in red down the middle here. And then the other meridians are going out in opposite directions from that central line. And you can see that they spread out, and each segment is 15 degrees wide. And as you travel across them, the time moves by 1 hour each segment. So the prime meridians mark the centre of each of the time zones. So can you see that GMT, the prime meridian, is running through the centre of this yellow segment here. And then the purple segment next to it, you would be 1 hour more. Then the green segment, you would be plus 2 hours. The red segment would be 3 hours in advance or 3 hours forward in time. And if you go the other way, this would be minus an hour, and then the red one would be minus 2 hours, and the green would be minus 3, and so on right to the outside. And altogether, there are 25 time zones. And there's 25 because if you can see, the minus 12 and the plus 12 are split into 2, and you've got the 0 one in the middle, which is where the prime meridian is. So altogether, there are 25 time zones across the world. Let me show you it on here quickly. Sometimes it's easier to understand it when you can see it appearing as you're watching. So we've got our 24 hours, and we're splitting the Earth up into 24 equal segments. And each of those segments is 15 degrees wide. And they're called time zones. So each time zone is worth 1 hour. So the time in this one is 3 p.m. in the afternoon. As we move around, we get to 4 p.m. And then the next time zone, we would be 2 hours ahead at 5 p.m. If we went back the other way, so if we moved, for example, instead into this time zone, we would be going 1 hour back in time. We'd be moving back 1 hour earlier than the purple segment. So that would be going back to 2 p.m. So that is why if you're in a country that is quite close to the UK, the time zone only changes by a little bit. But if you go to a country, say Australia over here, which is a long way from the UK, there are a lot of time zones that you have to cross to get there. And that's why the time zone is very different. For example, the time difference to the coast of America, if you can see here, is 1, 2, 3, 4, 5 hours behind the coast of the UK. If we're going forward to Australia, 1, 2, 3, 4, 5, 6, 7, 8 to that part of Australia is 8 hours in front. So if it's midday in the UK, it's going to be about 8 o'clock in the evening in Australia. And it's going to be about 7 o'clock in the morning in America, because we're doing 12, take away 5 hours for America, or the east coast of America anyway, the bit nearest us, which would give us 7. And for Australia, we are doing 12 hours, which is what it would be in the UK, add 8 more. So it would be 8 o'clock in the evening. We're going to come back to the international dateline now, because some people might be wondering, well, if each of these segments adds on 1 hour to the day as I move around the Earth, then what would happen if I just kept going round and round and round? Or what happens if I go backwards, if I go in the other direction? Well, just like the prime meridian goes through the UK and marks midday, there's another line, the international dateline, which is the opposite meridian. So it's on the exact opposite side of the world, which means that if it is midday in London or in the UK, then it is midnight at the international dateline. And this is what the international dateline looks like. This red line here looks like on a map. Now it's not straight, and you might notice that it doesn't go through any land. I want you to have a think about why that might be. Well, you've probably worked it out. Imagine if you worked night shifts and you worked on a Monday, but you didn't work on a Sunday. If you had the international dateline going through your city or your town, then it would be one day on one side of the dateline and another day on the other side of the dateline. And that could get extremely confusing. So that is why this dateline is not straight and why it goes through the water. But you can still get some pretty cool things that happen with it. For example, if you get a flight that goes from Australia to California, you can arrive before your plane's taken off. And if you travel from Samoa, or Apia, which is a town in Samoa, to American Samoa, so there's a little map down here of 2 little islands here. So if you travel from this island to this island, which are less than an hour apart from each other on the plane, you cross the international dateline. And because you've crossed it, when you arrive, the clocks will tell you that it's 23 hours before you've left. So time travel does exist, but only for 23 hours ago. So here's the final bit before the last part of your quiz. This flat map of the world shows how the time zones are actually used. And you will probably have noticed that they are not quite as straightforward as lovely segments out of a chocolate orange. There are quite a lot of wiggly bits that go around different countries or certain islands. And there's some countries which use the time zones in quite a different way. They're strict 1 hour usage. So although almost everywhere has used universal time since 1929, so almost 100 years, the time zones aren't used in such a standard way, and there's lots of different reasons for this. It mostly has to do with which countries communicate with each other a lot, and a lot to do with the islands as well that are in the oceans. So pause the video and just have a look and see what you can spot. Look for countries that you're familiar with and see what you can spot about the time zones. If you have a look along the top and the bottom, you can see that they're colour coded. So everything in this red zone here is in the universal time, the Greenwich Mean Time. And you can see here that that includes the UK, includes Iceland, even though it's technically in the -1 hour time, and includes part of Africa here. But it doesn't include quite a lot of these other areas that would fall into it if it was a straight segment. They are using the +1 time, which is the next segment along. So have a look and see what countries you can spot and why you think the time zones might work like this. Now, there are all sorts of weird and wonderful things going on with time zones around the world. And when you get onto your independent mini project in a moment, there is a wee video that you can go and watch that tells you quite a lot about some of these weird and wonderful things. I'm going to tell you very briefly about one or two of them just now, but you can go and find out much more. So not all countries use time zones in 1 hour blocks. Some of them use time zones that move in half-hour blocks, and one or two even use them that move in just tiny 15-minute blocks. There's also some countries that use just one time zone across the whole country, even though the country is really very large. So this is a great example here. I'm not going to tell you which country it is because you will maybe want to go and find that out for yourself. This country here all uses the +8 time, so it's 8 hours in front of UK time. But this one right next to it here, the dark green one, is only +5. And so if you walk across this boundary here, take one step from one side to the other, it could go from 5 o'clock in the afternoon to 8 o'clock in the evening in the space of one step. So there's some really weird things that are going on with time zones around the world. And there's some islands that have been moved from one side to the other, so they lost a day. So I recommend you go and have a look at the video that is in your mini project instructions, and you might even want to go further than that and do some more research of your own. I'm going to leave you just now to finish off your quiz questions and to go and get started on your mini project. There is quite a lot of choice with your mini project, but I've given you some success guidelines for the sort of the basics that you need, and then I've given you some ideas of some more details and some more interesting things that you could go and look up as well. Thank you for listening. Good luck with the last part of your quiz, and I hope you enjoy your mini project and you find out some weird and wonderful facts about places in the world. Bye for now.